Hello, everyone, and welcome to Quality Simplified, a channel dedicated to quality concepts. Friends, in our professional career, we come across many problems every moment, every day. Some of these problems are very simple in nature and can be solved within no time. However, there are some issues which are so difficult, so serious in nature, that if not solved in time effectively, can lead to serious financial impact. To handle such issues in professional world, especially in engineering world where I spent years of my professional career, I've seen people using certain methods to understand the root cause of the problem and finally solving them. These methods are nothing but broad guidelines to be used in certain sequence along with domain knowledge, expertise to solve the problem successfully. But one more observation is different methods follow different steps, which at times becomes very confusing. Over a period, when people start using these methods, they develop a feeling that these are empirical formulas and anyone can solve any problem using these methods without having any domain knowledge, which is incorrect. If this was true, we wouldn't be required to go to doctor to solve our health problem. In today's session, we'll try to understand why in many cases we fail to find a root cause and solve the problem successfully using these methods, and also what could be done to avoid these failures. I'll be explaining each and every step with its importance and the logic behind to make you understand better. Also, at the end, I'll be suggesting, based on my experience, certain set of steps to be followed, which will reduce the possibility of failures considerably. We'll call this process of root cause analysis and corrective action as RCA in this video for the sake of convenience. Also, two words, defect and problem, I'll be using quite interchangeably, and I request viewers to please take a note of this so avoid confusion. Since this is a very critical subject and has to be discussed quite comprehensively, I split this video into two parts. First part will start with definition of a problem and will go up to containment action at the end of customer to avoid serious financial impact or loss of credibility depending on the situation. In second part, we'll start with discovering a root cause and finally solving the problem as a preventive solution at system level. So let's begin with first part. Welcome again. We are discussing root cause analysis and corrective action, part 1. So let's go ahead. Before we proceed, let me share with you that these are purely my thoughts based on my experience in quality for 3 decades. I don't claim that this is the knowledge on quality. All viewers are free to have their own views on the subject, and I would be too happy to know your views, comments, so that we all can help each other in improving our understanding of conceptual quality. Also, examples used here are with certain assumptions for the sake of ease of explanation. Viewers are requested to keep this in mind while watching this video. So, let's proceed further. Before we proceed, as per our practice, let us just reiterate action points for delivering quality to our customer. These are: know or identify your customer, understand the requirements in advance, which will help you to plan better. If we can get it directly from target customer, that would be best. Strive to satisfy these known requirements, and finally, receive feedback and act as necessary. To deliver good quality, we must remember and practice these mantras and make it a way of life. The process of RCA starts the instant problem is reported by customer in his or her own verbatim, which will not be necessarily in actionable form. For example, it could be mentioned as part cannot be assembled, part is rusted, threads are slipping, and if it is a personal word, the problem could be reported as pain in the stomach, feeling of weakness, and the food is not tasty. It's not great in taste. Customer verbatim statements tells us what customer is feeling which is against his or her expectation. However, as mentioned, we cannot take any action on it unless we define it more elaborately. For example, food is not tasty. It does not tell you anything about what exactly is not right unless we inquire more about it, we probe more about it. If this is not done through probing and we take some action, can be at times misleading as well. However, whatever is the situation, it is very important that we listen to customer complaining to us about problem patiently. Moving further, we have to rephrase the customer's verbatim in scientific terms to move towards resolving issue. In this way, we try to understand the nature of problem in more details. This has to be done by proactive probing, asking relevant questions. For example, food is not tasty. Instead, if we rephrase it by getting some more information like it's too salty, too sweet, or it's too spicy, it's not fully cooked as well. That will make huge sense. Taking some more examples, let's see how we can rephrase them. Pain in stomach. We can understand through probing that it pains continuously or there is a sudden pain intermittently. It pains after I eat some specific type of a food, or it pains only in the morning, or it pains when I lift some heavy object. Part cannot be assembled. One part is oversized and hence cannot be assembled, or hole positions on two meeting parts are not matching for screwing them together. Feeling of weakness. I feel weak in the morning or in the evening. I feel weak after I do some small work. Energy depletes very rapidly. I feel less energetic throughout the day. Idea is to understand more about nature of a problem which will help you solving it. Understanding more about problem with data and its analysis. This is very significant step but generally overlooked, mostly unknowingly. Reason being, since we get so much dependent on tools and not many tools ask for these details, so it's generally overlooked or not well understood. Having detailed data to elaborate the problem many times gives clues leading to root cause. For example, suppose we discuss that threads are slipping when applied with certain level of torque. The details about the problem could be collected are how many pieces or percentage of them have failed, have they failed in one shift, one day, was the operator same, was the tool same when it failed in another shifts, was it not failing with other operators handling same machine, was tool changed, reset, recalibrated before it started failing, have all parts which have failed belonging to same batch of production, have they failed consecutively, or all parts have failed after a certain time, or there was some event after which parts produced are failing. Now just see how this data can give you leads to likely root causes. How many percentages have failed? If it's high, tells you that there is some common reason which has touched all the parts, which could be tool, operator, machine, etc. Also, generally a high percentage of total population failed may lead to product or process design inadequacy. Consecutive failures, one batch indicates likely root cause could be tool, machine, material, operator in that batch. Resetting, recalibration of tool implies there could be some big thing which is different before and after resetting of a tool. It is always preferred to add drawing, sketch, photo of a part, failed part, which gives best idea than writing thousands of words. Some problems can have photos, but some cannot. For example, high absenteeism, frequent failure of logistics arrangement. Here, graphical presentation of data may help for faster interpretation. Data so collected and analyzed will help in moving towards root cause clues, will imply for interim containment action depending on the scale or intensity of a problem and its impact. These containment actions at times may be felt unnecessary but has a large contribution in reducing negative impact of complaint technically or emotionally. After detailing its time to have a look at need we do something to contain the impact of a problem at customer end in case parts are already in dispatch or in the hands of customer. In a situation where the number of parts affected by problem are very high or even with small numbers, the likely impact on customer end user is going to be very serious. In such cases, it is advisable that supplier has to take some action to protect customers' interest. If the defective parts have already left your dispatch dock or have reached customer or beyond, some action at customer's end is must. This not only reduces the cost of correcting the situation later, but when it goes out of hand, it also increases your credibility if informed proactively, which is very important to sustain and grow in business. The likely actions could be stop dispatches from customers' premises to end customer, segregate for bad parts and allow only dispatch of good parts, rework the defective parts before dispatch, give alarm to the field and go for corrective action campaign immediately, inform, give customer confidence that though parts are defective, there is no immediate reason to be worried about. We'll handle it as and when it gets reported at our cost. This can happen if the defect is only reducing life of a parts like tire, brake pads, driving belts, etc. and not causing any functional issue prematurely. So friends, we'll be taking a pause here for part 1 and we'll continue in second part. I hope you are clear with the steps discussed so far and I would suggest please watch part 2 immediately without any gap to keep link in mindset intact. If you like this video, please subscribe this channel, recommend others to subscribe, watch and like. Also, let me know if the knowledge information shared is helping you and if you need any specific areas to be added in future videos, comments. So friends, with this, let's meet in part 2, that is next video session where we'll go one more step ahead in understanding quality. Till then, goodbye.